Hello everyone. If you're watching this, I'm dead. Just kidding. I'm at the hospital. My wife's giving birth to my son. There's that. Today we're going to be talking about strength of materials testing. In strength of materials testing, they use a machine called the universal testing machine, which is what we're going to talk about today. Our outline is going to consist of the overview of what's being measured, fundamental principles of the science behind measuring strength of materials, the various techniques employed, the history and evolution of the science and the testing machine. We'll take a look at some sample results, the limitation and uncertainty of the machine, some comparable techniques, and finally we'll look at the future of the science. Now, what is being measured? Stresses and strains are being applied to test specimens. As we all understand, stresses and strains are simply different forces applied axially, transverse stress, shear stresses, things of that nature. Structural changes within the body are observed and recorded. These structural changes are allowing us to see how a specimen is observing under these stresses and strains. The behaviors include necking, bending, buckling, stretching, cracking, shearing, things of that nature. So we're allowing a specimen to act naturally under certain scenarios or certain applied forces, and we're observing the behavior under those applied forces. These behavior of the material under predictable environments and uses allow us to understand how a specimen will act or behave under a predictable environment. So for example, if we have a structural beam set up under, we would apply a axial load to that beam as if it was a support. This allows us to see what kind of buckling or bending or cracking would occur at what points. This ultimately allows us to find the factors of safety. And as we all understand from our solid mechanics and machine design courses, this factor of safety is a representation of how much a specimen can withstand, how much force a specimen can withstand before it begins to fail. Fundamental principles and the science behind the machines. Now, these governing equations should all look very familiar. We have stress as a force per unit area, Young's modulus, which is stress per unit strain, and strain is simply a difference in length and the ratio of its original length per change in length. And Poisson's ratio is a differential in transverse and differential divided by its differential in the axial direction. And so we have different governing equations set up that as a general governing equation to help us guide or help us understand what is happening in material science.